Okay, so we're supposed to suppose that fx is discontinuous at x equals -3. So we don't know what the function looks like, but at -3, it's discontinuous, but they tell us it's defined at x equals -3 such that we get a y value of -9. So there's a dot down here. Now there's a couple of different ways that this function could be behaving. It could be doing something like this, and then it's an open circle, and then it starts up like this again. The function could be like this. No, sorry, it could be like this. Open circle, then like this. So those are two very different things, okay? With this function, the slope, the instantaneous slope appears to exist, because when you for a derivative to exist, the slope from the left and the slope from the right need to match each other. So here, if you were to draw a slope just a tiny bit to the left and a slope just a tiny bit to the right, the limit as you get closer and closer to -3 would match. But with this other function that I imagined, actually I think it was like this, doesn't matter. It's a jump discontinuity. Oh, actually those slopes would be the same. Let me do something a little bit different. Let's say it looks like this. That would be a jump discontinuity. And the slope from the left side of -3 would be positive. The slope from the right side of -3 would be negative. So the big idea is you want to consider what's happening with the slopes as you get infinitely close to -3. If they match, it's differentiable. But they haven't told us enough information to say that whether it looks like this function or the function I just drew here. So select all statements that must be true. I mean, they say it's defined at -3. Oh, and they also say it's discontinuous at -3. Yeah, okay, so either way, that would be discontinuity. The limit as x approaches -9. This is swapping the y values with the x values, so we can rule that one right out, okay? When we're evaluating a limit, we talk about it with respect to the x variable, as x gets closer to -3. It says it's defined at -9, but that doesn't necessarily mean that the limit is going to be -9, because look at since they haven't told us what the function looks like, it could look like this new blue function I just drew, and the limit as x approaches -3 here would be 0, but for the defined value it would be -9. So this one is none of the above. None of those make sense. We can't be sure that it's differentiable at x equals -3. Just because it's defined doesn't mean that it's differentiable. We just drew two examples to show that. We drew a jump discontinuity. We don't know that for sure. The limit as x approaches -9 is nonsense. It's supposed to be the limit as x approaches -3, and that doesn't necessarily have to equal -9 like I just demonstrated. So none of the above with this tricky question. Remember, a derivative is just a slope. It's just a slope at a particular point. So a derivative tells us how much the y value changes per x value. So y divided by x. So with this function here, it makes a perfectly vertical slope, it seems to be at x equals 2, right? Because it's vertical and that's an undefined slope, because that'd be an infinite change in y divided by no change in x, you could say, or a 2 change in y divided by, it's a divide by 0 problem because there's no change in x here for the instantaneous slope. It'd be a vertical line. And as we've learned before, vertical lines have undefined slopes. So you probably recognize this by now. This is the definition of the of an instantaneous slope. So it's the derivative at a point, and the point is 5. If you can take a derivative at 5, then it's continuous at 5. And then if we can evaluate this derivative, it comes out to a number that must mean it's differentiable. Limit is x. So differentiability implies continuity. That's one thing that we say a lot in Calc 1. Okay, if you can take a derivative, it implies that it's continuous, which this is the definition of continuity right here, right? The limit as x approaches 5 of fx equals the exact value. And then if it's going to be continuous, then this also must be true, that the limit exists in the first place. Continuous at 9, we're not saying anything about 9. X equals 9 isn't what's happening. Remember, a limit evaluates and gives you a y value, not an x value.